All right, so we're taking a look at this problem here that asks us to calculate the chi-squared test stat that would be used to test the claim that the following hypothesis is true. And to do this problem, I'm going to use the advantage of a calculator that can allow me to do calculations like this all at once, so I don't have to work it out in a table format, which is so time-consuming. So as I've mentioned in one of the other videos, you don't need to have a very expensive calculator to do what I'm going to do. You just need to be able to see what you're typing into the calculator easy enough so that you can work out expressions like this without having to do them in a step-by-step fashion. Because that method is so time-consuming. If you're able to type it all in at once, it really makes it so much easier. So I'm just going to demonstrate how that's done here in this video. This problem, of course, was done in another video where we worked it out using the table. Here we're going to do it just using the fractions and adding them all together. So first thing I'm going to need to do is come up with my n for the problem, right? Because we need to know the expected values to use that formula above. And the expected values are just defined as n times p, and of course it's ei is equal n times pi. The I just means that we'll have different expected values depending on what the hypothesis says for the different categories. So for example, if I want to know what the expected value is for group A, then I'll have to take the sample size, which we can work out very quickly here in my calculator. So let's do that. It's 140 plus 80 plus 250 plus 30. All right, when you're done, you get exactly 500. So n is 500 then. And with that information, we just need to plug in the PA. So what's the probability for group A according to the hypothesis? They say it's 25%. So 0.25. All right, so there you have it. And if you work that out, you're going to get 125, correct? Because essentially for every 100, you'd have 25. We have 5 of them. That's 125, pardon me. Okay, so there's your expected value for A. And then, of course, we do the same for B, right? The expected value for B. And we do the same approach. It'll be 500 times the probability for B, which is 10%. And 10% of 500 is just 50. Okay, so now we have the expected value for B. Let's work out the expected value for C. So the expected value for C is just, again, 500 times the probability for C. According to the problem, it's 60%, so 0.60. And that would, of course, give you 300. And then lastly, we need the expected value for group D. So it'll be 500 times the probability for group D, and that group is just 5%, 0.05, and so that will be 25 when we're done. Okay, and of course you can see that the sum of these values adds up to 500, right? So 300 and 100 make 400, that's 425, 475, 500. If you add the expected values all together, they should add up back up to n because these probabilities have to add up to 100%. Okay, good. So now that we have that set up, our next step of the problem is to take these expected values and to plug them into this formula. Now look, we have 4 expected values. We're going to need 4 fractions then to fill in. So I'm just going to put the space together one by one for each problem. So the fraction for A would be the observed value for A, which is 140, minus its expected value. The expected value for A is 125. Quantity squared over the expected value 125, right? Plus, then we'll have another fraction. Open up the fraction, put in 80, minus the expected value for B. So B's observed value is 80, its expected value is 50, so we put in 50, close it up, square it, and remember, divide by the 50, the expected value. And then another fraction, right? So we'll have a fraction again. This time we're doing it for C, so the observed value for C is 250, minus the expected value for C we found to be 300. Then we're going to close that up, square it, and divide by the expected value of 300. Okay, and then one last one here. So let's see if I can squeeze this in on the edge of our page here. I'll put in the observed value for D, which is just 30, minus its expected value, and the expected value for D is just 25. And we're able to squeeze that in. It looks like the expected value is 25 here. All right, let's work out these 4 fractions then using our calculator instead of that table format and see how quickly it's done compared to what we did before. Okay, so I have my calculator set up. Open the parenthesis. I'm going to type 140 minus 125, close the parenthesis, square it, divide by 125, plus, open parenthesis, 80 minus 50, close parenthesis, square it, divide by 50, plus, open parenthesis, 250 minus 300, close parenthesis, square it, divide by 300, plus, open parenthesis, 30 minus 25, close parenthesis, square it, and divide by 25. Okay, after entering all into my calculator, I get approximately 29.13 repeating. So my chi-squared test stat is approximately 29.133. All right, so there it is. And again, I do believe that using your calculator's ability to work these steps out all at once will save you a tremendous amount of time. And again, almost any calculator, even the inexpensive ones, can do this for you. It's just a matter of whether you're comfortable enough working them all out at once in the calculator. But even if you can't do each fraction all at once because you're afraid, doing the whole string all at once because you're afraid you'll make a mistake, at least try doing a single fraction at a time and then write those 4 fractions down and add the results together by hand with your calculator. That'll still save you time from creating that whole table we created before. So again, in the videos for the problems, I worked out the process using the table, mainly because I wanted to make sure that even people using the most primitive calculators could do the calculation themselves. But if you have a better calculator, try to use this approach. It's a lot faster.